So today we are working on multiplying polynomials, which basically is distributive property going crazy. So for our first problem, we have 5x squared times the quantity of 3x minus 3y plus 5. So we're going to be distributing this 5x squared to each of these terms. So 5x squared times 3x. We can combine these x's because we're multiplying, even though they are unlike terms. But we have to remember that when we multiply similar based exponents, the exponents add. This x here has an invisible exponent of 1. So 5 times 3 is 15. And then x squared times x to the first power is x cubed. So then we have 5x squared times negative 3y. So we'll start with the coefficient. 5 times negative 3 is negative 15. Now these don't have the same bases, so we can't really combine them. But similarly to how this 5x squared is the same as saying 5 times x squared, we can just kind of combine these variables like that, x squared times y, into one singular term. So then for this last one, we have 5x squared times positive 5, which leaves us with 25, and we just bring along this x squared. Now, even though we have two x squareds here, because this y is attached, these two are not like terms. So we have no more like terms, so this is our final answer. Now that might be something that you've probably done already, but it's a good segue into our more difficult problems, like negative 4xy times 7x cubed plus 4y squared plus 8x squared y. And again, we're going to distribute this negative 4xy to each of the terms within the parentheses. So we're going to start with the coefficients. Negative 4 times 7 is negative 28. And then each of this x and this y has that little invisible 1 exponent. So x times x cubed gives us an x to the 4th. And we just bring that y along for the ride, since there's kind of like a y to the 0 power here. 1 plus 0 gives us our 1. So then we do our negative 4xy times 4y squared. So negative 4 times 4 is negative 16. We don't have an x in this term, so the x just comes down. And I'm writing the x first because it's good math grammar to write your terms in alphabetical order. I'm not entirely sure why, but that's just how it is. So then we have our y1 times our y squared. So we get y cubed. And then our last term, negative 4xy times a positive 8x squared y. So 8 times negative 4 is negative 32. X to the first power times x squared is x to the third. And then y to the first times y to the first is y squared. And we have to double check that we don't have any extra like terms. We don't. So this is our final answer. It's a rough circle, but you get the picture. All right. For our third one, we have x squared plus 5 times x plus 1. So what we're doing here is we're basically going to be distributing this whole x squared plus 5 to each of these terms. So x squared plus 5 times x plus x squared plus 5 times 1. So I'm going to rewrite this problem showing this distribution. So we have our x times our x squared plus 5 plus our 1 times x squared plus 5. So we're going to distribute this x, and we get x times x squared is x cubed, x times 5 is 5x, and then anything times 1 is itself, so we can just bring down the x squared plus 5. Now you can leave your answer in this form because we don't have any leftover or like terms in this problem, but math grammar again, so I'm going to just rewrite it to x cubed plus x squared plus 5x plus 5. And that's your final answer. For our fourth problem, we have the quantity x plus 5 times the quantity of 2xy plus 3 minus 2x. So again, we're going to be taking this entire piece, this entire x plus 5, and distributing it to each of these pieces, each of these terms in this quantity. So we have our 2xy times our x plus 5 plus our 3 times our x plus 5 plus our negative 2x times our x plus 5. So then we're going to distribute each of these terms. So we get our 2xy times x gives us 2x squared y, and then our 2xy times 5, we get 10xy, and then we get 3 times x is 3x, and then 3 times 5 is 15, and then negative 2x times x gives us a negative 2x squared, and then a negative 2x times 5 gives us a negative 10x. Now here comes the part that's a little tricky to see if we have any like terms left. I see one like term. We have this plus 3x and this negative 10x. So I'm going to combine those so that way we are left with a 2x squared y plus 10xy, and then 3x plus a negative 10x leaves us with a negative 7x plus 15 minus 2x squared. And that should be your final answer. And if your numbers are in a different order, as long as you have the same numbers and the same sign in front of each of the numbers, you'll be okay. Now I do have a challenge problem for you that I want you to try. You can try it if you want to, you don't have to. It is difficult. But it'll be x squared plus 4x plus 3 times 2x squared minus 9x plus 7. So for this one, I'm going to be multiplying this entire piece by each of the terms in that piece. So we're going to have 2x squared times x squared plus 4x plus 3 plus negative 9x times x squared plus 4x plus 3 plus 7 times our x squared plus 4x plus 3. It's a lot of distributing. It's a lot of work. So we're going to distribute all of these pieces out here. So we have 2x squared times x squared leaves us with 2x to the 4th. And then 2x squared times 4x gives us 8x cubed. And then 2x squared times 3 gives us 6x squared. Then we're moving on to this one. Negative 9x times x squared gives us negative 9x cubed. Then negative 9x times 4x gives us negative 36x squared. And then negative 9x times 3 gives us negative 27x. And then 7 times x squared gives us 7x squared. 7 times 4x gives us 28x. And then 7 times 3 gives us 21. Now that is a lot of numbers. Doesn't even fully really fit in my camera well. So this is definitely a good time to use of highlighters, underlining things, all of that fun stuff. Things that I love, because I love colored pens and highlighters and all of that fun stuff. So we have our first term of 2x to the 4th. We don't have another term like that, so that'll be our only pink term. And then we have our x cubes. So we have our 8x cubed. We also have a negative 9x cubed. And that is our only cubed numbers. And then we have a 6x squared. We have a negative 36x squared. A positive 7x squared. And that's it for our squared terms. And then we have a negative 27x and a 28x. And then we have one lonely green term of 21. So now we're going to combine all of these terms. Like I said before, we only have one x to the 4th term, so we're just going to take that. And then we have our yellow terms, which is 8x cubed minus 9x cubed, which gives us minus a negative 1x cubed. I'm going to cross these out so that way I know that I've used them. So then we have our 3 purple terms, which is a positive 6x squared minus 36x squared plus 7x squared, which leaves us with a negative 23x squared. So we're done with our purple terms. We're left with our blue terms, which is negative 27x plus a positive 28x I did that wrong in my notes. Good thing I checked that. All right, so negative 27x plus 28x gives us a plus x. And then we have our singular green term here, which is plus 21. We don't have any extra like terms in our final answer, so this is the final answer to the challenge problem. Congrats on anyone who got that right, because I didn't on the first try.